Assalamualaikum. Hi everyone. In our previous video, we explored the basic properties of electric charge. Now, let's see how charges interacted using Coulomb's law. This fundamental law helps us calculate how strongly two charges attract or repel each other. Now, how do we calculate this force? Coulomb's law is given by the equation F equal to K Q1 Q2 divided by R square. Here F is the electrostatic force, Q1 and Q2 are magnitude of the two charges and R is the distance between the charges. K is Coulomb constant which has a value of 9 into 10 power 9 Newton meter square divided by Coulomb square in vacuum or air. This formula tells us that the force increases if the charges are large and it decreases if the distance between them increases. In Coulomb's law, the constant K is related to any physical quantity that called permittivity of free space. It's represented by the symbol of epsilon naught or epsilon. This relation is K is equal to 1 by 4 pi epsilon naught. This permittivity tells us how easily an electric field can pass through the vacuum or empty space. Its value is approximately epsilon naught equal to 8.85 into 10 power minus 12 Coulomb square divided by Newton power minus 1 meter power minus 2. So, the force between two charges in vacuums depends not just on a charges and their distance but also on this fundamental constant of nature. What is the difference between vacuum and medium? Vacuum medium அப்படிங்கிறது என்னன்னா vacuumங்கிறது ஒரு empty space with no matter and mediumங்கிறது any material of the substance like air, water, glass. In simple wordsல சொல்லணும்னா vacuumங்கிறது ஒரு எலக்ட்ரிக் ஃபீல்டு வந்து ட்ராவல் ஆகும்போது வித்தவுட் எனி அப்ஸ்ட்ரக்ஷனில் வந்து ட்ராவல் ஆகும். மீடியம்ங்கிறது வாட்டர் பிளாஸ்டிக்கில் போகும்போது எலக்ட்ரிக் சார்ஜுக்கு இடையில உள்ள இன்ட்ராக்ஷனை வந்து அதோட ஸ்ட்ரென்த்தை வந்து ரெடியூஸ் பண்ணும். தட்ஸ் வை த எலக்ட்ரிக் ஃபோர்ஸ் ஆர் ஆல்வேஸ் வீக்கர் இன் எ மீடியம் than in vacuum. Here, Coulomb's law in vacuum is written as F vector is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square R cap. R cap is unit vector from one charge to other. Now, when the two charges are placed in a medium instead of vacuum, the electrostatic force between them is reduced. The formula becomes F vector is equal to 1 by 4 pi epsilon Q1 Q2 divided by R square R cap. Here, epsilon is the permittivity of medium. Means the permittivity of any medium epsilon is greater than epsilon naught. This means the mediums always weaken the electric force between charges compared to vacuum. Next we see force of direction. Coulomb force is a vector. It means it has both magnitude and direction. We know already if the charge are same, they repel. If they are opposite, they attract. Coulomb's law follows the inverse square law. This means force decreases rapidly as distance increases. Here, see the image. If we double the distance between two charges, the force becomes 1 by 4th. For example, இப்போ ரெண்டு மேக்னெட் இருக்குது. அந்த ரெண்டு மேக்னெட்டையும் பக்கத்தில் வைக்கும்போது என்ன ஆகும்? அட்ராக்ட் ஆகும். அப்போ அங்கே ஸ்ட்ராங் ஃபோர்ஸ் வந்து க்ரியேட் ஆகுது. இப்போ அந்த ரெண்டு மேக்னெட்டையும் என்ன பண்ணுறோன்னா தூரத்தில் வைக்கிறோம். தூரத்தில் வைக்கும்போது என்ன ஆகும்? தூரத்தில் வைக்கும்போது டிஸ்டன்ஸ் அதிகமாக இருந்துச்சுன்னா அதோட ஃபோர்ஸ் வந்து எப்படி இருக்கும்? கம்மியாகும். சிமிலர்லி இன்வர்ஸ் ஸ்கொயர்லாவும் இதே தான் ஃபாலோ ஆகுது. See, if we triple the distance, the force becomes 1 by 9th. This is why electrostatic force are very strong when charges are close, but weakens as they move apart. Now, Let's see how Coulomb law follows Newton's third law of motion. Remember, Newton's third law says for every action there is an equal and opposite reaction. This means that if one object exerts a force on another, the second object pushes back with the same force in the opposite direction. Now consider two charges Q1 and Q2. If Q1 exerts an electrostatic force on Q2, then Q2 also exerts a force of the same magnitude of on Q1 but in the opposite direction. So, when the force is attract or repel, both charges feel equal and opposite forces. This mutual interaction between the charges show the Coulomb law perfectly obey Newton's third law. Let's look at the formula side by side. Coulomb law F is equal to Q1 Q2 divided by R square, where Q1 and Q2 are charges and K is Coulomb constant. Next, gravitational law F is equal to G m1 m2 divided by R square, where m1 and m2 are masses and G is the gravitational constant. Coulomb law is electrostatic force between two charges. Gravitational law, the gravitational force between two masses. Coulomb lawல ரெண்டு சார்ஜஸ் வந்து என்ன ஆகும், ஃபோர்ஸ் நேச்சராகவே அட்ராக்ட் ஆகும் இல்லைன்னா ரிப்பல் ஆகும். ஆனால் கிராவிடேஷனல் லாவில் அட்ராக்ஷன் மட்டும்தான் ஆகும், இட்ஸ் நெவர் ரிப்பல். Force between earth and moon. So, even though the formula look like similar, Coulomb's law governs the tiny world of charged particles, and while gravitation rules the vast universe of stars and planets. It's important to note that Coulomb's law is strictly valid only for point charges. That is, charges that are assumed to occupy no space. But in reality, a point charges is just an ideal concept. All real charges are spread over some value. So when can we still apply Coulomb law? We can use it for two small charged objects like metal sphere, as long as their size are much smaller than the distance between them. In such cases, the object behave almost like point charges. In fact, when Coulomb first discovered his law, he used charged sphere in a torsion balance. The distance between them was much larger than their radii, so they could be treated as point charges. This approximation works very well in many practical situations. See, let's solve a problem to apply Coulomb law. Two charges Q1 equal to 5 mu Coulomb, Q2 is equal to minus 3 mu Coulomb are placed 10 centimeter apart. What is the electrostatic force between them? We use the formula F is equal to K Q1 Q2 divided by R square. We know that already the constant value K 9 into 10 power 9. We substitute this value and two charges Q1 Q2 value are given 5 into 10 power minus 6 into 3 into 10 power minus 6 divided by the distance 0.1 whole square. We have multiplied this, we get the value 13.5 Newton. Means one charge is positive and other charge is negative, the force is attractive, pulling the charge together.